Before we move on to the next topic, let's review the current code and see if we can do any improvement or any fix. The first thing that I can see here is that there's a bunch of using or imports that are not used, and we can easily get rid of them by using the wizard, which has the option to remove unused usings. And now we're back at with only the ones that we really need. So actually we only need 2 using. I see that there are a few constants, like the port number being 9010, and the fact that this port is not checked for its validity. Only one application can bind to any given port. So if it so happens that there's another application that is already using port 9010, this program will fail. Also the port number is hard-coded, so that's not very good. But since it's a demo app, it's not too much of an issue. Ideally, this constant should come from a configuration file. Next thing I see is 128, another magic constant, and that one is not actually purely random. 128 is believed same as a so max econ, something like that, and that value represents the number of pending connection that would be queued in case they are all incoming at the same time, and my application doesn't have time to accept them. So 128 is pretty large, and you could get away with like 10 or 20. It's the size of a buffer somewhere in kernel space, and it's not that much memory used anyway, so we can leave it at 128. There is also this constant of 100k. So the size of the buffer is quite arbitrary, and as we saw earlier, even if the message that we're getting is longer than 100k, we would not be failing, because we would just go through another iteration of the loop. And so whether it's 1k or 100k, it's pretty much the same. This value here may raise some questions. Why 102400? Why not 100k, 100? Why not any other value? So it may be worth putting a comment. But other than that, it's not super surprising. And there are many times where buffer sizes are quite arbitrary. Also, there is no real reason to have 1024. It's 2 power 10, but the fact that we're using base 2 makes no difference here. Next, we have this line string buffer that we actually don't need anymore, so we can remove that, obviously. The compiler would do that anyway for us, so it's not a big deal, but it's still good to remove dead code that we know. The next thing here is also cosmetic. I prefer to switch around these 2 lines because I would like to have the logic of the closing logic. So we open a connection and we do some processing, and then when you close the connection, so the closing is the mirror of the opening. So I print the message first, then I add it to the sockets list. So I do the reverse when I close. So I remove it from the sockets list first, and then I print the message. So in this particular case, it's also not very important because all we do is really printing a message. So it has no side effect to our main logic. There are cases where it's important to do the operations in the reverse order, and there are 2 blank lines that we can remove. This code is very short. Another thing that we can see here is this encoding ASCII get string. I briefly mentioned this earlier, but this I believe requires some more explanation. Don't have time to do this now, but I think I will do another video just on encoding, because it's quite tricky for English speakers. We are kind of lucky because ASCII is our privileged alphabet, and we can get away with only using ASCII for most of our applications. But for Chinese speakers, they don't have the luxury of not knowing about encoding. Let's talk a little bit about the structure of our program. We migrated from a purely synchronous application, the one we had before, towards something that is already quite asynchronous in a sense, because if we look closer, we're no longer in charge of the operations that are executed. Depending on whether we receive a connection from the user or we receive data, we would be entering the socket listener equal the first part of the if, socket equal listener, or the second part where we know it's a socket that is associated with the connection. Reading on this code, this is no longer linear. So the code that we execute is impacted by external factors. This comes as no surprise, since we are writing a server and we are replying to connections and messages coming from clients. The clients will be the one that will be driving the flow of our application, and this kind of behavior is typical of asynchronous application. We will be working on this code further and further, but the main point remains the same. We actually can see that there's already the premise of our main design pattern, which is the event loop, by the fact that we see this while true. So the code around the main logic is looping forever. Normally we should have an exit condition, of course, but for simplicity we're looping forever, and it's blocking on the sockets.select. So this is something that we'll see quite often. A main loop that has a stopping logic that is mainly for exiting, and an operation that is blocking. This operation blocks until it receives some external input, and then the logic after that is about interpreting that event and doing our processing accordingly. So this is basically what the event loop is.